Hello and welcome to this video. In this video, we want to look at a question under the topic nuclear chemistry. And before we can look at this question, do not forget to subscribe to our YouTube channel and follow us on our Facebook page if you have not done so. If this video will be beneficial to you, please like the video, comment on the video, share the video so that we know how you are enjoying this content. The question that we want to look at reads: a nuclear reactor produces 20 kg of uranium 235. If the half-life is about 70 years, how long will it take to decay to 0.1 kg? From the question, you can notice that we have been given the initial mass, we have been given the half-life and the final mass. Now, when it comes to nuclear chemistry, in particular questions under half-life, we have these two equations that we use. The two equations come from chemical kinetics, that is the first order reactions under chemical kinetics. So, nuclear reactions obey the first order reaction of the chemical kinetics. What do these two equations tell us? The first one tells us that the natural log of the mass at a given time divided by the initial mass is equal to negative multiplied by the rate constant multiplied by time. Or we can use this equation, which will say the natural log of the initial mass divided by the mass at a given time is equal to rate constant multiplied by time. The second equation is half-life is equal to 0.693 divided by the rate constant. Now, when you look at the first equation, you will notice that the first one, we have put a negative sign here. Then the second one does not have a negative sign. So as a student, you need to choose which equation is of comfort to you. Is it the one that has a negative sign or the one that has no sign at all? How do you differentiate the two? The one with the negative sign, the final mass is the numerator, while the one with the positive sign, the initial mass is the numerator. From the question, we have been given the initial mass, the half-life, and the final mass. So we have not been given the rate constant and the time at which the mass was 0.1. In fact, the time at which the mass was 0.1, that's what the question is demanding. So the first thing we need to do is to find the rate constant. So how do we find the rate constant? Because we have been given the half-life, we can use the half-life and the second equation for us to find the rate constant. So we can divide this side by 1, then we cross multiply. So get the rate constant is equal to 0.693 divided by half-life. So we have 0.693 divided by the half-life is 70 years. So let's divide 0.693 divided by 70. We are getting 0.0099 as the rate constant. So we have the rate constant there now. The rate constant is 0.0099. We now have the rate constant, so let's find the time t. So for this video, I'll use the second equation to show how you can find the time t, and at your own time, try to use the first equation and put in the comment section to confirm that the first equation is the same as the second equation. So let's use the second equation to say natural log of the initial mass divided by the mass at a given time is equal to the rate constant multiplied by that time. So we have natural log of the initial mass is 20 divided by the final mass is 0.1. Then this is equal to the rate constant. We are just from finding it, which is 0.0099. Then t there. So natural log of 0.1 into 20, it gives us 200 is equal to 0.0099t. So what is the natural log of 200? So natural log of 200, natural log of 200 is giving us 5.298 is equal to 0.0099t. So we divide both sides by 0.0099, 0.0099. So we are saying this answer we have on the calculator, we are dividing into 0.0099. We are getting that t is equal to about 535 years. So it will take 535 years for the 20 kg to reach 0.1 if the half-life is 70 years. So we have used the second equation. You try using the first equation, and we hope this video was beneficial.